Consider this word problem: making of a Vernier scale. Design a Vernier scale to subdivide the main scale into divisions of 0.2. The smallest division on the main scale is 2 units. Now you'll note I'm not using any units here whatsoever. This could be for inches, could be for millimeters, could be for centimeters, could be for meters. I'm just going to make a Vernier scale just using just plain numbers. So it says here, I need a main scale that has divided into 2 units. So I'm going to draw a ruler. I have here a bar which has no indications on it. There's no scale on here because I'm not using a scale. I just want to draw a line. Try and draw a straight line. I'll start the line about here, here. And I'll draw a straight line to about here, I guess. And it says here the smallest scale division on the main scale, we'll call this the main scale. It will be 2 units. So I'm going to draw some segments on here freehand. I could use a ruler or something and make them evenly spaced, so I'm just going to do it freehand. I'm going to start here at 0, and we'll call this 2 units because every space is going to be 2 units. There's 2, there's 4 from the 0 to 2, 4, 6, 8, and we'll call this one 10. So 2, 4, 6, 8. So every division is 2 units. And I can carry on. 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. You're getting a little small. You've got to stretch them out a bit more. 32, something like trying to make them same as that one. 34, 36, 38. Make that 40. And 42, 44, 46, 48. Make that 150. And we'll stop here. We'll just ignore the rest of that. So there is my main scale in divisions of 2 units. 2 millimeters, 2 inches, 2 feet. It doesn't matter. I'm just using straight numbers here, dimensionless numbers. And then it says here, design a Vernier scale to divide the main scale, this main scale, into divisions of 0.2. So I need to divide this segment between 0 and the 2 into smaller divisions of 0.2. If I were to do that, and I'll just do that over here somewhere. I'm going to move that and put it here. There's my 0, there's my 2. And this is asking me to divide this into segments of 0.2. So it'll be 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.82. So there are 10 little divisions in here. Each one will have a value of 0.2. Mathematically, we can do this. We require, mathematically, each main scale division is 2 units. We want to divide each one by 0.2, so mathematically, therefore we require 2 units. And each one is going to be divided into 0.2, or we want 0.2 increments within. 2 divided by 0.2 tells me I need 10 divisions within that segment, and we just saw that here. But that is difficult to see. If I were to write those in here, and I try to make a measurement to this kind of discrimination of 0.2, it's difficult to see. So what if we were to take this and blow it up, make it bigger, stretch it out? Stretch it out from here, 2, 3, 4, 5, 6, 7, 8, 9, 10 to here. Stretch it out. And that's the idea behind making a Vernier scale. Take those all squished up in here, stretch them out so we can see the individual ones much better. I'm just looking at my notes. So we want 10 divisions. Now we need to build a vernier scale, and I'm going to use this sliding paper to do that. To build this particular scale, I'm going to count, how many do I need? I need 10 divisions. So I'm going to count 10 divisions on the main scale. This is going to be my vernier scale. Starts here. I'm going to count 10 divisions. I'm going to use the main scale as my ruler. I'm going to count 10 divisions on the main scale. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I'm also going to subtract 1. So I'm here at 9, and that's going to be the length of my vernier scale from there to here. It's 10 minus 1 will be the length of my vernier scale. I'll just write it over here. In this case, it's 10 minus 1. So 9 main scale divisions. 9 main scale divisions. So the length from here to there is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 divisions. I'm ignoring the numbers. I'm not looking at the numbers. I'm only looking at all the various lines that I have here. Count 9 lines. That'll be the length of my vernier scale. Now I need to divide this into 10 even spaces. It says here, make it into 10 even spaces. So dividing this as being my vernier scale into 10 even spaces. Let's see. From here, I'm going to move away from that because it's sort of giving me some bias as to where to do this. So half is about here. And I'm going to do this into individuals. 1, 2, 3. 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10. Individual, evenly spaced. This is going to be my vernier scale. And if I put my vernier scale back on here, it'll reach from 0 to that 9, or the 9 divisions on the main scale. This effectively has taken all of these little divisions in here and now I have moved them here. And each division here on the vernier scale has a value of 0.2. From here to here is going to be the same as from there to there. So this is 0. And all the way to the end, because I've moved that and I stretched it out, comes here, 2. Now dividing this evenly in 10 even spaces, 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8, 2. 2 divisions. So each one of these now is 0.2. 1, 1.2, 1.4. And this is now my vernier scale. And if I want to make a measurement, I would slide my scale, this being on a slide. And let's say I want to make a measurement, say to here. And then on my main scale, I would count how many units to go across. And here I got 10. This would be in 2s, 10, 12, 14. 14 prior to my 0. So it's 14. And then on my vernier scale, find the lines that match up. The one that most matches up is this one right here. And there might be some parallax depending on the camera. But I'm going to say it's this one right here. And the value of that one is 1.2. There's 1.8, 1.2, 1.4, 1.6, 1.8. So add the 14 plus 1.8 from the vernier. And therefore this right here would be approximately, looking at this, That's 10, 12, 14, be 15, looking at it, 15 something. And more precisely using the vernier, there's 8, 15.8. Of course, my divisions aren't evenly spaced, but this value here would be 15.8 using my vernier scale. And this is the basic method of building a vernier scale.